So after the weekend's job for me with the scrap President KP77, which we managed to resurrect, whatever this is will be easy, he says. Rotel 240. Yep, nothing else. Wrong screwdriver. My bench mat is migrating. Okay, speaker on one side. Oh my goodness, yes. Yes, he's... Yep. See what his letter says. Quick power test, nothing came. Checked the fuse was not blown 2 amps. Noticed the solder side has been messed with. Capacitor 10's leaked. Top's popped. That wants some, you know, do you remember we made those covers in our organ workshop so that the little cloth washers so that you can't see the switches? It wants some of those. Good. So from that I think it's a dead set. Not the right screwdriver. Well, it's been overvolted, hasn't it, to do that? Might as well switch the soldering iron on now. So the driver transistor has been replaced. It's not too messed up. There's a bit of a mesh around the synthesizer. He's probably right. It's probably had a illegal modification and it's been reversed. Gets rid of solder splurge. Right. Take that capacitor out. Out you come, and it's positive towards me. Luckily it says so on the radio. You look, well, this probably says it works perfect, but we know it's it shot its load. Open circuit. So it's 1000 microfarads at 16 volts. So I'll pause the video, go and get one. So 1000 microfarads, 25 volts, and this is a Nikon. So pop that in there. I wondered what fell on the floor. It was the reel of solder. So I'm holding it with one hand and soldering it with the other. Yeah, it certainly wouldn't be up to much with that. Power supply on. .8 volts. And dead. So we've got the voltage on the volume control. And that is switching. So I'll check by the protection diode. We've got power there. Okay, it was actually in PA mode. It must have slipped in transit, so just make sure some of these are in a sensible position. And we're in public address mode, and you can hear it coming through my external speaker. That's always a nice test, and it's useful when a radio has public address, just to facilitate tests. So put that into the normal socket. I don't actually have any volume. Plug in. Mind you, it's always possible that duff capacitors killed the IC. Oh no, can't have done with working in PA. I am telling you a load of bunkum. We'll get another known mic out of stock. I'm not sure that that's wired for Cybernet. So I'll just go and dig one up and we'll put this meter away for now. As soon as I put it away we'll need it again, so that's good logic. Okay, so a bit later on we've got to the stage where we find that transistor Transistor 19 to SC1318 is open circuit and it's become a diode. The resistor there, 10 ohms, which is just down there, was short circuit. Now I think this set's been 24 volted. So I've looked in our parts department, which is pretty good, and did I find any Mitsubishi 2SC1318s? No. I've ordered some, but I found one on a scrap AM chassis, which we bought in at some time from a radio rally, no doubt. Wow, that one works. So, this is why you have these things. So that's the one that doesn't work, so that can go to one side. Now, it's never as easy to insert parts that have had the leads snipped, and what I'm going to do, I'm just going to make sure it goes in from the other side first. Because you can just end up with a bit of solder on something. That goes in alright. Then we'll feed it in on the surgical Caesars. So by replacing that resistor I mentioned, which was 10 ohms at half a watt, at least we've got power up to this voltage regulator. Without this you've got no receive rail, and without the receive rail you've got no transmit rail either. So they kind of originate from the same point, but they do differ. So, get in. You see, the next hour of this video will be me trying to put this transistor in. Let's hope it doesn't. Do you know what? I've gone to put it in backwards. I've gone to all that trouble to feed it through. I can't even follow the shadow on the printed circuit. There we go. So I'm going to hold on to that with one finger. We're going to have to kind of put some. Where's the solder gone? There's about 5 yards come off the reel. This is what you end up having to do to solder things in. There we go. That's one leg. I've changed the electrolytic capacitors on both the rails just as a precaution. They're both read kind of alright, but you know, after 38 years it seems to be the sensible thing to do. So having wound up all those yards of solder, none of the Zeners don't seem to have died. So we'll put the meter back on. I'm going to be poised in a particular position. That's a bit better. So have we got anything on the synthesizer? Yes, we have. 4.7. That still looks a bit low. We now have an RX light lit. So if I press transmit, we've got TX light. So let's look at that other voltage rail down there. 6.45, that's about where that should be. It's still not working. Unless I've got some switches in a silly position. What we've not got is any receive audio. I can actually hear some receive. It's not responding till we get to 100 microvolts, but I can hear some very low volume receive. So we're going to have to go further into this. Just putting my finger on that resistor we've replaced. So I think something's drawing excessive current. Now we know the audio amp works as we did with the public address test. We'll just go back to that, make sure we're working. Yeah, we certainly are working. So I'll look at something which controls the squelch circuit, because that's not getting its power. Right, I'll take a break from our tea and we'll take it from there. So my next bit of logic here, because the voltage is low, so instead of producing what I'd expect to be 8 volts, we're producing about 5. So the Zener diode, so this is where we've had the, I've changed the capacitor, we've changed that resistor, which was open circuit, and it says 9.1 volts. So I've taken the Zener diode out, just zoom in a bit on this. I can't even tell which way around this is. So it's 1.2 that way. It's 0.65 that way. So I've got a new, bit more powerful. It's just that we stuck 1.3 watt ones rather than 400 milliwatts. And this should be 9.1 and it's 9.03. So, out of interest, what does it read if you put it the other way around? 0.7. So I think we've got a Zener diode that is iffy. So put that in. Right. Now let's see what happens. So now we've got 9.25 volts. Let's take the camera back to its normal position. So on the top of that Zener we've got 9.2 volts. On the next Zener we have got 3.3, which is still low. So what does that mean we've got on the synthesizer? 3.3. So I wonder if diode 2 is also damaged. So we'll put our head in it. Okay, so I've taken diode 2 out. So let's see what that has to say for itself. I suspect this one's damaged as well. Oh, 6.1. Oh, perhaps it isn't. Let's see what it's supposed to be. It's going to be 6.2, so it's right. That's right. We'll put it back. Okay, folks, we're finally there with it. I think this is the third 90-minute session. This has clearly been 24 volted and is, well, it's somebody I get a lot of emails from, and we discuss a lot of things with, and he's a fellow radio amateur and all that kind of stuff, and he was the person who very kindly redid me the words part of the service manual in a bigger typeface. So basically the sets have been 24 volted, and I don't know what we said on video over the last couple of days, but it's put me behind schedule with other repairs, but I didn't want to abandon it. So I'd got there's a number of, I'll use this different type of circuit, a pretend one, with a better layout, to be honest. Let's make sure we're in the right camera. So basically the Zener there was short circuit. If that's the Zener, if I've got the right glasses on, I'll put the right glasses on. So we had the capacitor that was blown, which would be there, that one. So you've got to receive 8.5 volts and a receive 8.6 volts. So once we'd restored the receive 8.5 with a transistor replacement, resistor replacement, resistor replacement, resistor replacement, Zener replacement, then we actually found what was dragging it down was the FM chip. So the FM chip is toast and go in the vertical filing cabinet. Try and keep his costs down. I've recovered one off a scrap chassis, so we'll just charge him a fixed pound for that. So I did take the phase lock loop chip out as a precaution, and I've put that back in, and it's clearly at one time been messed with, Whether or not it's had illegal channel modifications and been reversed, I don't know, but it looks that way. So we now have a radio that's receiving. So we'll go back to our normal position, short out the power lead a few times. But I mean, the fact is all those shroud washers are missing. That front panel's been off. I bet it's been off on a lot of occasions. It's a real messed up with set. So we'll get these set up. Yeah, the dimmer doesn't work. So what's somebody done to that? Well, it looks like it's been shorted into the always on position. That could mean the potentiometer's faulty, and I will not be changing that. So we'll start off with the VCO. So for the first time, we'll use his set of instructions and select channel 40. So resistor 4, and we need to be on 4 volts. It's just a little bit high. Where have I dropped my tool? There? No, I haven't dropped it at all. It's there. Oh, apart from power supply transistor, the receiver transistor was short circuit, and I've changed its feed resistor as well. So all these blue metal high stability resistors are the ones I've fitted. Okay, so we'll now check that we've got that in transmit. I'll select picture in picture, and for the first time it looks like we've got 3 watts on transmit. We've got 3.51 volts. We'll just pop that trimmer to 4. Probably. So that's now high. I think we'll have that there, and that's there. Good. So now we go to channel 1, and they want us to be somewhere between 1.8 and 2.5, which we are going to transmit, and it's the same. So we'll put that meter away, and I'm only sorry we've got 1 or 2 sets piling up here, and this has caused them all to be running late. So there we go. So let's start with the transmit. So it's doing 3 watts exactly as it's arrived. Let's just pop it on frequency. I'll show you the frequency counter. Now it's neither here nor there, this. To all intents and purposes it's pretty well spot on. 79112, bring that up to 79115 if I can find the trimmer. Trimmer's there. There There we go, actually spot on today. Go back to this one. Make sure we've got maximum there. Yep, that's maximum. Maximum, the one under wiring. So now at 3.5 watts. Luckily none of the cores are broken, which is good. These want to be all maximum at this stage. And this is the important bit because of getting the balance right. I don't think this one's going to do 4 watts. They usually do it easily. Yeah, 3.6. I don't know whether the phantom coil mess has been in here. Looks alright. Let's see how it is on other channels, because normally we need to be balancing this. 3.3 watts on channel 40, 3.5 watts on channel 1. So if this radio was cold, it would be doing a bit more power than this. I mean, sometimes we can get approaching 5 watts out and then drop it down to 4, but it isn't going to happen. Okay, let's look at low power. Switch it. It's actually correct. It was. These are often dirty, and this is no exception. There we go, 400 milliwatts. Back to normal. It's you know, having done low power, gone back to that, I should sort of do 3.7. So I think we can safely say it's a whisker away from 4 watts when it's cold. I've had it now on transmit for about 8 minutes continuously. And if we turn the power up to the point at which my car would be charging, 14.4 volts, the radio is doing 4.1 watts. So the radio will do it. We're setting this at 13.8. So, let's look at the power meter on the front. If we can see, it's banging the needle across, that needs altering. So we'll make it so it reads the 4. Meter lamp's out, so you may not be able to see this. That's now reading 4. Deviation, what surprises have we got here? Wallow. Oh, it does 3.5. How wonderful for it. I bet everybody can hear him fantastic on their highly selective Fidelity 1000s. but not on good quality sets. So set that to centre, that to about there, and let's see how it performs now. Wow, it's absolutely spot on. Maximum of 2.5 and averaging 2.2. So that's covered that. I did make sure the mic gain was there. It's in nice condition, apart from the fact some Wally's managed to 24 volt it. It's had a lot of wear, but it's nevertheless in good condition. So I think that's covered transmit. Okay, let's go over to receive. So we will put the oscilloscope on. We'll switch it on, I think, I'll help. Turn the bench light off. And as the CRT warms up, we should have a waveform. We have. Just turn the volume down so that we've got a useful range on the screen. So I've changed the FM chip. So we now need to set the detector coil with the appropriate tool. So the detector, one maximum recovered audio. No, that didn't need adjusting, that was spot on already. We'll put the bench light back on, we'll go over to the Cybernet meter. So at the moment, the sensitivity on the radio, bearing in mind I changed the transistor in it, is, because it was about 100 microvolts before I did that, it's a shade away from 3 microvolt, 0.3 of a microvolt. Let's just see where it is. 0.3, yeah, it's 0.35 microvolts for 12 decibel Cybernet. So it's already exceeding the manufacturer's specification, but we will go through it. See whether we can get another ounce out of it. So the first coil there. Tell you what, we have. I don't believe it. Drop the attenuator. This is going to be as good as my reference RVC240. I'll put a bit more signal on for this one. No, they've not been messed with. So let's see what the sensitivity is now. It's 0.3 of a microvolt, 0.29, something like that. For 12 decibel Cybernet. So let's go back to, let's look at the attenuator controls, I think. So we'll put S9 on the signal generator, which is 100 microvolts just there. And what we want is S9 on the meter. Well, it's pegging the needle. So we'll adjust the preset for the meter. So that's now reading 9. And we'll now check the squelch out. So with the squelch now on full, I want the squelch to open on full at S9, which is 100 microvolts for a CB in the UK. So 1, 3, 10. It's coming in at 10, so it's far too sensitive. So we'll turn that up. You can see the wear on this preset. You know, it's really been, that's it, 100 microvolts, really been fiddled with. So we'll now turn the signal generator to standby, set the squelch to threshold, and switch the signal generator back on. It's come in. Wow. Right down to 0.1 of a microvolt and coming in at that's 0.1, that's 0.21. So very, very sensitive squelch, and squelch often lets the Cybernet 134 down. I'm just going to go back to transmit. It's now had 5 minutes to cool down. Let's just see what the power is at 13.8 volts. If the power supply was at 13.8 volts, I'll just make sure it is. And let's just key it up for a second. It's 3.6 watts. So at a higher voltage, it will do the 4. It's always possible these transistors have been changed and they're not quite the right ones, but the customer is not going to want that kind of expense. The radio is doing the power it's supposed to, but only just. So I think we're done. Yes, I think we need to take this front off, make some washers, and get rid of these gaping holes. I don't know whether to let the customer change the meter lamp because he does first line repairs. I'll think about that while I make some washers in the organ workshop. Okay, so here we are with the meter lamp in it. The dimmer's now working for what it's worth. Someone just put a short across, it was always at full. So there we go. You know what I never did check? Whether the channel 9 switch really was channel 9. And you know what? I've switched off the test gear. Because it can be instant 19 with a change of a link. So just change my radio to channel 9. Flip the switch. Testing 1, 2. 1, 2, 1, 2. Well, that's not doing anything. Testing 1, 2. Testing 1, 2. 1, 2. It's been changed to 19. I'm going to have to whip the lid off and change the link. That is really annoying. I've just thought we've done. There's always something. Mind you, I think we're very lucky that this is working at all after the quite considerable damage it's had. I've already had to have the lid off again because there was a tri-joint on the resistor for the meter lamp, so it was on and off for like nothing at all. I just suspected this, and I should have checked it earlier. It goes to pin what? 9, doesn't it? Channel 9 goes to pin 9. Yes, channel 9. Make sure we're switched off. You've got instant 9 and instant 19 on the LC7137 synthesizer chip, and because somebody's messed with the labelling on this, and it says, instead of saying CH9, they've scraped away a bit of the H, so it says C19. Well, of course the display still says 9, So we just need to pop that back to how it should be. So we'll take that wire off there and we'll pop it on there. And now, if I put my little hand portable on, testing 1 2, testing 1 2, testing 1 2. We're now on 9. Mind you, channel 19 switch would be more used, wouldn't it? But that's not how it's supposed to be. I know how to go in and out this set soon. 7 o'clock. I've been on with it since I think I've done 2 90-minute sessions on it today. 2 90-minute sessions on it yesterday. There's lots of thinking time as to what's happening, especially with these destroyed power supply circuits, how it's distributed and what the avalanche effect is of one knackered part, shall we say, to another part of the circuit. Apart from the capacitor, it did work in PA mode, didn't it? So here we go. We'll switch that back to there and see if there's anybody out there. 19 Roger. 19 Roger. Good, nobody on as usual, just how we like it. Right, that's all ready for our on the air test. Switch the soldering iron off and switch all the test gear off. Thank you for watching the badly damaged 24 volted Rotel RVC240 for our customer.